Hello viewers, welcome taking you through the story for O-level mathematics. And this video we are going to go through the expected response for the senior 1 math end of term 1 paper for the year 2024. So this video is suitable for students in both in senior 1 up to senior 4. So previously I was combining the videos for both O-level and A-level into one YouTube channel, but I received a comment that some O-level students are finding it hard to identify their videos from those of A-level. So what I did, that is, I created a new YouTube channel for strictly O-level material and of course competence-based curriculum. So today we shall go through the expected response for the senior 1 end of term 1 for the year 2024. I think you are aware that now the questions are more of scenario. There's nothing like section A, section B as we are doing in A-level. For O-level it is somehow different. So let's look at item 1. So item means a question. What you used to call question is now called item. And what you used to call solution, we now call it expected response. Okay, so question 1 says, Mukasa is a book supplier and keeps a track of the records. Hope this is, I don't know if this A, maybe. And keeps a track of the record of the number of books supplied per term using abacus drawings. Okay. For the year 2023, his supply records book for the 3 consecutive terms of the year had the following drawings. So we have that, we have this, and we have that. Okay. When he presented these records to his immediate supervisor, the supervisor failed to interpret the diagrams and preferred that the books sold be recorded in dozens, since they are easier to count that way. He therefore instructed Mukasa to come up with a single base 12 abacus showing the total number of books sold for the whole year. Mukasa doesn't know how to go about it. Task: help Mukasa come up with a single base 12 abacus drawing. So first of all, this is under number bases, the very first chapter in senior 1. So we have to first get this, read this. When you see 5, when you see, let's see, if you see this 5s, 5 5s, 5 5 5s, it means that this is now base 5. Then this one also base 5, base 5. So our work is to first read off these abacus drawings in base 5. If you look at this, here there is 1, 2, 3, 4, 4, then this is 3, this is 2, this is 1. We are counting the number of beads. So this will be, this for term 1 to be 4, 3, 2, 1, base 5. For term 2, I'm seeing here 3, I'm seeing here 2, 1, and 4. So term 2 will be 3, 2, 1, 4, base 5. Then for term 3, it is 2, 4, 0, 3. So term 3 will be 2, 4, 0, 3, base 5. Okay, so let's see. Let's come and write that down. So first we need to write down the other bases we saw for term 1, for term 2, and for term 3. Then from there we need to add all of them, because remember they want the total abacus drawing, in base 12, but for the total item, for the total books sold. So we are going to first get the total in base 5 and see how to convert to base 10. So when let's add. If you add 1 plus 4 plus 4, it gives you 8. But remember we're dealing with base 5, so we can't write 8. What do? We shall say that 8 is the same as 1 remainder 3 in base 5, because 8 divided by 5 you get 1 remainder 3. So what we do, this remainder is what we write here, and this whole is what we put up here for the next place value. Then we got the next. Now 1 plus 1, that is 3, 3 plus 1, that is 4, 4 plus 0, it is 4. 4 can be written in base 5, so our work is to just write the 4 as it is. The next is now 3 plus 2, 5, 5 plus 4 is 9. 9 cannot be written in base 5, so what we do, 9 is the same as 1 remainder 4, because when you say 9 divided by 5, you come up with 1 remainder 4. So what we do, we shall write this 4 here, and we carry this to the next place value. So write 4 and carry that. The next is to add. This plus this is 5, plus 3 is 8, plus 2 is 10. So 10 cannot be written in base 5, so what we do, we find the equivalent. So 10 is the same as 2 remainder 0. So what we do, because they have no other place value here, we are going to write 20 here. So that is the total books sold in all the terms when we are writing in base 5. But remember, they want your answer in base 12. So what we do, we have to convert that to base 12, but we cannot convert it directly. So what we do, we are going to first convert to base 10. So converting to base 10, you put place values. You put here 1, you put here 0, 1, 2, 3, and 4. So here it will be, let's start from here. This will be 2 times 5 to the power 4, 0 times 5 to the power 3, 4 times 5 to the power 2, 4 times 5 to the power 1, and lastly 3 times 5 to the power 0. Then next is to use the calculator to come up with the total in base 10. Now before we go to the next slide, let's see marks for the slide, or the scores. Okay. So now we have to convert that to base 12. We shall come and write our 1373 base 10. Base 12, that's why we write here 12. Now this divided by 12, you come up with this remainder 5. Then we divide again, this divided by 12, you come up with 9 remainder 6. Now this 9 is smaller than this, so you stop there and say this base 10 is the same as 9, 6, 5 base 12. Okay, now we are done with, now we can draw our abacus which is needed. We put beads basing on the place value. 1s are these ones, 12s are these, and 12s are here. So let's put the beads. We shall put there 5 beads. Then 12s we shall put there 6 beads. And 12s we shall put there 9 beads. So basically that is what they wanted. That was item 1. Now we shall go to item 2. Item 2 says, Mwebesa is a fruit seller. Okay. In order to meet his customers' needs and maximize sales, he sells fruits in various piles as follows. A pile of 3 fruits at shillings 500, a pile of 5 fruits at shillings 800, a pile of 7 fruits at shillings 1200, and a pile of 10 fruits at shillings 17,000, and a pile of 12 fruits at shillings 12,000. One day, Mwebesa, this should be E, Mwebesa got a deal of supplying fruits to a certain construction company. He has 420 fruits in stock, but does not know which pile of fruits will give him maximum profit if all the fruits are sold. The task: help Mwebesa to determine the pile which will give maximum profit and how many piles they will be. So you shall come and say that to get the amount of fruits per pile, 3 fruits per pile, we shall get the total divided by 3 to get the number of piles, but each pile is 500. So number of piles are 140 multiplied by 500 to get the total amount. Same applies to 5 fruits. Number of piles are 420 divided by 5 to give you 84, but each one is 800, so you come up with this amount. When there are 7 fruits per pile, number of piles are 420 divided by 7 to give you 60, but each pile is 1200 to give you a total of 72,000. When there are 10 fruits per pile, number of piles are 420 divided by 10 to give you 42 piles, but each is 1700 to give you a total of 71,400. Then when there are 12 fruits per pile, the number of piles will be 420 divided by 12 to give you 35, but each is 2,000, so you come up with a total of 70,000. That means that now the maximum will be 60 piles. Do you see this? If you look at all these prices, the maximum will be this. And for you to make maximum profit, it means you must make maximum sales. So that the sales, and therefore he'll be selling 7 fruits per pile, and the total number of piles are 60. And basically that is what they wanted. So that's how the question item could be scored. So now we shall go to item 3. Item 3 says, a twinny has a rectangular field measuring this by that. He wants to place fencing posts along its sides at equal distances, such that the posts are placed as far apart as possible. Okay, here's support material. Part A, task A. Help a twinny to determine the distance he can use between the posts such that they are placed as far as possible. Part B, how many posts are required to fence a twinny's field? So when they say as far as possible, that becomes a highest common factor. So we shall come and get the HCF of these two measurements. Begin by 12. When I divide this by 2, you come up with this. This divided by 2, you come up with this. They are still divisible, so divide by 2 still, you come up with this. So this divided by 2 is that, this divided by 2 is that. These ones are still divisible, so this divided by 3 is this divided by 3 is that. So that is the end. The rest cannot be divisible, so we stop there and say HCF is this product, which gives you 12. Therefore, if the trees are placed as far apart as possible, the distance between the posts is 12 meters. Then for part B they said how many posts are required to fence the field. So one shall need the perimeter. Perimeter is 2 in brackets length plus width. 2 in brackets length plus width to give you this. And they say the space between each 2 posts is 12. So I'm going to divide this total length by 12 to get the total number of spaces. Those are 268 spaces. Then from there we shall know that from the support material, if the field is circular, it implies that the number of spaces between the posts is equal to the number of posts used. Therefore, you can conclude that there will be 268 fencing posts. And basically that is what they wanted. Then item 4, Sarah is organizing a school event and needs to distribute identical gift bags to pupils. Okay. Each gift bag contains an equal number of pencils and erasers. She wants to ensure that the number of pencils and erasers in each bag is the same with no leftover. Okay. The pencils come in packs of 8 and the erasers come in packs of 9. Task: help Sarah to determine the smallest number of pencils and erasers she has to put in each gift bag so that there are no leftovers. So when they say here there is smallest, so smallest means lowest common multiple. Therefore, expected response, I'll come and get the LCM of 8 and 9. Divide by 2, you get that. So this divide by 2 is 4, but this divide by 2 is not possible. There's a remainder, so just leave 9 there. Then again 2, this divide by 2 is this divide by 2, there's a remainder, so you just write 9. Then again 2, this divide by 2 is 1, this divide by 2 there's a remainder, so we leave it as 9. Then now this, so here I've already reached 1, so I'll need this. This divided by 3 is 3. And this divided by 3 is 1. So when all are 1, you can stop there and the product will be the LCM. So I can conclude that Sarah has to put 72 pencils and 72 erasers in each gift bag to ensure an equal distribution without leftovers. And that's what they wanted. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on Senior 1 Math Mid of Term 2. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so you can all benefit as a family.